So as the air exchanges from one direction to the other, those air doesn't actually touch. Now, what's trying to happen in nature is you've got two different temperatures. Say, for example, you've got 20 here and 0 there. The middle wants to be 10. So as this air exchanges, the heat exchanges at the rate of the airflow. So if this is faster and that is slower, it will change at a different rate as if it was the other way around. That's how you can control the amount of energy or the amount of heat that is exchanged within that heat exchanger, which is why it's important to have different airflows at different rates, two independent fans. So that is how we get our efficiency. That can be up to 92% efficient. That's the heat exchanger. MVHR, mechanical ventilation and heat recovery.
John, you talked about the efficiency, the difference between, say, 70 and 92%. How does that help you in terms of sort of from a health point of view and also from an energy point of view?
Now, when it comes to percentages of exchange, in other words, how efficient something is, obviously the higher or the better the efficiency, the higher the percentage, the more heat can be exchanged. But in some circumstances, you may not actually need much heat recovery. You may not need that amount of volume because you're in an area which produces more heat than what you want. So therefore, a lower percentage of exchange could be right for a particular design or office or factory or a working area. So therefore, the percentages or the heat exchange rate may need to vary purposely for that job. This is why we have individual design, which is designed for purpose for that particular job.
How important is it to have an MVHR designer, someone who's skilled and understands MVHR?
When it comes to MVHR design, it's important to have people who do this. They understand the flows, because every room size has a variance. Well, you may have two rooms the same size, but it's in a different position of the house and a different function. So therefore, the airflow may require to be slightly different. So there are people out there that do this and do it very well. So I would always recommend going to somebody who has the ability to do a proper design for a mechanical ventilation and heat recovery. Go to somebody who does this, because it is quite important to have that correct airflow. They may even need to advise you what gap you need underneath the doors, because there's no point having airflow if you have no way of that air flowing from one position to another. So go to a designer and research them.
John, you mentioned just briefly humidity. How does an MVHR help humidity?
Humidity is controllable with an MVHR. It does vary in a number of different systems. Now, we all produce fluid. We all produce humidity. When we cook in the kitchen, we're boiling our potatoes, we have steam. We boil a kettle, we have steam. We have a shower, we have steam. Ourselves, every time we breathe out, we are breathing out moisture. So therefore, we're always putting moisture into the air within our build. So therefore, the MVHR will take that out and exhaust it into the MVHR system. And then that will be condensed and drip out through a condensing pipe at the bottom of the boiler, the bottom of the MVHR system, at the bottom of the box. So it's important to keep the humidity within the build at a constant given rate, because we produce different amounts of moisture at different points in the day. So therefore, we need to be able to stop damp, we need to be able to stop condensation. And the way we do that is to take it out via the MVHR.
You mentioned intake and exhaust. Whereabouts are these positioned? You know, do you have intakes in certain rooms, exhaust in certain rooms? Do you have intakes on the roof, on the floor?
When it comes to the MVHR design, it would be purposely designed. So therefore, it will be calculated where to make the most efficiency for the build. Usually kitchens, bathrooms, that area was where they exhaust, where they take the heat out. And usually living areas, bedrooms, are where the air comes in. And then we get our circulation. And that goes through, this is monitored by the MVHR system. Every MVHR system has a monitoring system, has sensors. It monitors airflow, it monitors temperature, and it monitors humidity. And the unit will adjust itself to be able to get rid of more humidity if you need it, and more moisture. And it can adjust itself. The fans will change automatically to try and keep the environment at set constant rate. So, and also the advantage of this is we can tell exactly what work the MVHR has done over a year or however long, because it's all stored. There is an app on the computer they plug in, and they can tell exactly how much energy has been used to heat the house, airflows, everything, and what the constants are. So everything is recordable on an MVHR system, and that will tell you how efficient it is and how it has been over the year, including the humidity.
Good stuff. Just wanted to touch on air pollution, really, and the, you know, we know how important or how widely acknowledged air pollution is now. There was, I think there's a case where certain homes on the M25, I think they experience air pollution at quite a high level. Yeah, just wanted to sort of touch on that, really, John. Just see what your thoughts are on that.
Air quality is a big thing to do with MVHR and an airtight build. If you've got an airtight build, it has to be controlled to keep it clean and keep it pure as you possibly can. That's why the filters in the MVHR will take out dust, insects, pollen, everything that comes in. It'll also help to maintain barrier, if you like, against gases and stuff outside the house, because some of these could be filtered and harmful materials can be filtered out. So an MVHR system is a consistent way of keeping healthy airflow, or as much as you possibly can within the environment outside your house.
Good stuff. I know that from my experience of actually showing people some of the houses that we've built, that if you have a condition, a breathing related condition, once you live in a house with an MVHR, it's almost very difficult to live in a house without an MVHR. I think it's a case of once you've experienced it, living in a home like that, if you've got a breathing related issue, I think the experience itself is quite hard to articulate.
When you have a respiratory lung condition or something like that, the MVHR system and the air tightness and the passive house is a very, very healthy environment. Now, when your body gets used to that, you can live much happier and healthier within that environment. When you get removed from that environment and you live in a different environment, it may be that your symptoms or whatever else seems to be accelerated or increased because you're used to being a little bit more healthier in your home environment. So that is an issue, but it's more a case of an awareness issue rather than a health issue. You're healthier in this environment, but when you put into the other environment, the symptoms and condition may seem worse purely because you're going back to where you were before than you were in the controlled environment.